Hi everyone, welcome back to the Organic Chemistry seminar video series. Today talking about intermolecular forces and boiling point. From my ranting about intermolecular forces for the past 7 weeks, I'm sure you're aware the intermolecular forces and thus the functional group that's attached to the carbon backbone determines all of the physical properties, including the boiling point. So, for the most part, higher the intermolecular forces, higher the boiling point. So we start with the hydrocarbons, the alkanes, alkenes and alkynes. They are non-polar molecules. And we know this because there is no significant electronegativity difference between hydrogen and carbon. I'm not going to go through that again. You guys should all know that by now. So hydrogen and carbon, no significant difference. So all we have is dispersion forces. So known as London forces, Van der Waals forces, so on and so forth. Then we move on to ketones, aldehydes and esters. They are all polar molecules. So if we're looking at the homologous series, so CH4 will have a really low boiling point if it is a hydrocarbon, so the H4 would be methanol. If it was a similar size molecule that was an ester, aldehyde or ketone, it would have a higher boiling point, and that's because it's a polar molecule and it experiences dipole forces. Now, spent the last 2 weeks going over the intermolecular forces in depth, so I'm not going to do that here. We then move on to the alcohols, amines, amides, and carboxylic acids. Now, they are also polar molecules. But they have a particular type of bonding. And again, you would have listened to me rant last week for an hour about hydrogen bonds. So they experience hydrogen bonding. So, if we were to take ethanol, ethane, it has a boiling point of minus 89 degrees. If we were to make it an alcohol, it has a boiling point of 78 degrees. So, increasing intermolecular forces between these three results in an increase in boiling point. Now, there's also a special kind of hydrogen bonding which is present in the carboxylic acids, which is this dimerization. So, two molecules link together to basically they form like a ring shape. I will attempt to do some really bad drawings. Basically they join together to create this shape. And you get a hydrogen bond here and a hydrogen bond here. So, ethanoic acid has a boiling point of 118 degrees Celsius, which occurs here. So dimerization occurs in ethanoic acid, boiling point of 118 degrees. Polar molecules with hydrogen bonding, so ethanol, 78 degrees. Ethane, hydrocarbons, only dispersion forces because it's a non-polar molecule, minus 89 degrees Celsius. So, as the intermolecular forces increase, so does the boiling point.